Hello everyone, I am audible.
Good evening, sir. Yes, sir, you're audible, sir.
Okay, so just a second, I think. Yeah, I'm audible.
Yes, sir.
Okay, yes, so let's start our today's class. So, hello everyone, this is lecture 14 on discrete mathematics. In the previous lecture, what we were discussing, I think we were discussing asymmetric relations now.
Yes, sir.
Okay, so we have done few questions also. And yeah, let me check which questions we have done till now. Okay, x plus y 10. Okay, so now we will say r is equal to x comma y such that x divides y, x divides y, okay, on z. Okay, so we have to check whether this relation is uh, asymmetric or not. Okay, so we were discussing asymmetric, na, or we were
Yes, sir.
discussing antisymmetric.
In infinite relations, in asymmetric only, sir. No, sir, it's antisymmetric we discussed, and A
Antisymmetric.
we have to start.
Okay, so antisymmetric. Till now we are on antisymmetric only. So we have to
Yes,
check r x y, x divides y on z. Is it ATS? We have to check this thing. Okay. So for antisymmetric, what we have to check, what was the definition? Definition was if x is related to y and y is related to x implies x should be equal to y. Okay, this thing we have to do. So let me check that out whether it is working or not. So x related to y means what? X by y, that should be equal to some integer. So I think I have told you, na, x divide y means what? Y by x should belong to an integer quantity. Okay.
yes, sir.
Yeah. So x related to y means sorry. So we have to write y by x.
Bikes.
Hmm. Y by x should be some integer k1, and y related to x means what? X by y should be some integer quantity. Let us suppose that is k2. So now we have to guarantee that from these two we should get x is equal to y. Okay, yes, so how we will get it? So I will simply multiply them. So after multiplication, say this is 1, this is 2. After multiplication we will get 1 is equal to k1 into k2. So now since both are integer quantities, so obviously k1 and k2 should be 1, or k1 and k2 are minus 1. There are only two possibilities. Okay, so k1 is equal to k2 is equal to 1, or k1 is equal to k2 is equal to minus 1. Okay, so when k1 is equal to k2 is equal to 1, so that means y is equal to x, the thing which we want, we have got it. But when k1 is equal to k2 is equal to minus 1, then what we will get? Y is equal to minus x. Okay, and the moment we get y is equal to minus x, problem will start. That means from these two we should conclude this, but we have concluded something else also. So immediately counter example will come to our mind. That is what? Say for example 3 upon minus 3. Okay, that is equal to integer quantity, that is what? 1, sorry, minus
1.
1, and
Minus
minus
3.
3 upon, that is also minus 1.
Mm.
So minus 3 divides 3 and 3 divides minus 3. Okay, but 3 and minus 3 are not same. So immediately I will say it is not antisymmetric.
Okay.
Any doubt? So this is the way to check. Okay, so this is the you can say this is one of the best way to check the things. Okay, because in gate exam you may or may not be able to find the counter example, because it's strictly a popcorn thinking kind of thing. So you may get or you may not get. So better is you follow the actual path or actual method. So I think you have got it now. I have just simply applied the definition of antisymmetric. X is related to y, y related to x. So conclusion should be x is equal to y. But no doubt we have got this conclusion also. But another conclusion we have also drawn. The moment we have drawn
Mm.
another conclusion, immediately I will say when y is equal to minus x. So I will say okay, 3 minus 3 or minus 3 3, and we have concluded that it is not antisymmetric. So x divides
Antisymmetric.
y on z is not antisymmetric. Okay, take snapshot. I will jump to the next slide.
Done, sir.
Okay, so the next question is same. We are doing same examples again and again. R is equal to x comma y is equal to x power I, such that there exists I belongs to z on z. Okay, yes, so what we have to do, so say same thing. Okay, because immediately we may not be able to find an counter example and all, so we will do simply like this: x related to y and y related to x implies x is equal to y, and this is true for all x comma y belongs to z. Okay, for every pair this should be true. Okay, so x is related to y means what? Y is equal to x power sum I1. Okay, and y is related to x means what? Y related to x means what? X is equal to say y power sum I2. Okay, so when both are true, then our conclusion should be x is equal to y. So consider this as 1 and this as 2. So it's your wish whether you want to solve in terms of x or you want to solve in terms of y. For example, we try to solve in terms of x first. So please let me know what will be the x from 1 and 2. X is equal to y power I2, but y is x power I1. So what should we say? X should be equal to x power I1. Okay, power I2. Are you getting it? X is equal to y power I2 when y is x power I1. So simply put, y is equal to x power I1, x power I1 power I2. Any doubt?
Understood, sir.
Okay, so finally x is equal to this thing. So from this what we will get, x is equal to x power I1 multiplied by I2. Okay, and that x means what? X power 1. So directly what we want to say, x power 1 is equal to x power I1 into I2. So I1 multiplied by I2 is equal to 1.
Yes,
So what does this mean? I1 is equal to I2 is equal to 1, or I1 is equal to I2 is equal to minus 1. Only two possibilities. We cannot have other possibilities because I is integer quantity. So you cannot say 1 by 2 and 2. 1 by 2 is not integer. So we cannot say like that. So either this or this. But we will not take this possibility. Why we cannot take this possibility? Because if I1 is equal to I2 is equal to minus 1, so x power minus 1, obviously it will be 1 by x, and 1 by x is not integer quantity, so we cannot take this thing. We have to cross it. So finally only one possibility, that is I1 is equal to I2 is equal to 1. So directly indirectly, what does this mean? When I1 is equal to I2 is equal to 1, so y is equal to x power I1, so y is equal to x, or x is equal to y power 1, so x is equal to y. So both are one and the same thing only. So final conclusion is x is equal to y. Okay, and you can do it other way around also. For example, in terms of y, you can also find. Okay, so y is equal to x power I1. Okay, so and x is what? Y power I2. So y power I2 power I1. Is it okay?
Yes, sir.
Okay, so finally what we will get, y power 1 is equal to y power I2 multiplied by I1. So same scenario, same thing. We will cut this and finally we will get this thing only, and this means what? X should be equal to y. Okay. So now if they twist the question a little bit, and in place of saying on real numbers, sorry, on integers, if they say on real numbers, then what should be the answer? If we take real numbers, so obviously this will have infinite solutions. Okay, so now this is also correct. I1 is equal to I2 is equal to 1. I1 is equal to I2 is equal to minus 1 is also correct. Okay, and I1 is equal to 1, I2 is equal to 1 by 2. There are infinite solutions. Are you getting it? I1 is equal to I2, sorry, I1 multiplied by I2 is equal to 1. Earlier our restriction was both were integer quantity, but now I am saying they are real numbers. If I say they are real number, immediately confusion will come to our mind. We can take say 1 by 2 and 2, 1 by 3 or 3, and so on. Okay, so we can have infinite solutions to this, and obviously x is not equal to x is equal to y. We sometimes we will be able to conclude it, or sometimes we will not be able to conclude it. For example, when I1 is equal to I2 is equal to 1, only then we can conclude this thing. But other cases we will not be able to conclude that. For example, when I1 is equal to 1 by 2 and I2 is equal to 2, obviously I1 multiplied by I2 is 1, na? Okay, and immediately problem will start. So for example, root 3 and 3 will come. Okay, 3 comma root 3 will also come. Are you getting it? So immediately 3 and root 3 are obviously not same. Okay,
Yes, sir.
so yeah, so it will create confusion. So whenever we see real number, we will simply cross it. Okay, so it will not work. Yes, take snapshot. I will jump to the next slide now.
Perfect, sir.
Okay, so now we are going to start asymmetric relations. Asymmetric relations. So you have to practice all these things. Only then you will get more clarity of it. Okay. Yes. So asymmetric, that is AS. We will shortly call it as AS. So what is the definition of AS? AS is very simple. It will say X related to Y implies Y should not be related to X. Okay, that is the very basic meaning. That means what? If we have X is related to Y, immediately you should conclude that Y should not be related to X. What was antisymmetric saying? Antisymmetric was saying if X is related to Y and Y is also related to X, then X should be equal to Y. But what it is saying? It is simply saying one thing, that when X is related to Y, Y should not be related to X. So directly you have got it. Self loops are not allowed. Self loops not allowed. Okay, and obviously ATS was less strict than AS. So every AS is ATS, but every ATS is not AS, because in ATS self loops are allowed, but here self loops are not allowed. So AS implies ATS. So directly indirectly this means what? If AS is this, ATS will be like this. Any doubt?
No, sir.
So same thing only. Okay, ATS and AS only same thing. The only difference is that self loop is not allowed in AS, but in ATS self loops were allowed. That is the only difference that we have got. Okay, so for example, I will give you a few examples just for the sake of clarity. 1, 2, 3. Relation R1 is say 1, 2, 2, 1, 3, 2. So see this. If 1, 2 is there, 2, 1 is not. Yeah, 2, 1 is also there. So immediately you will cross it. You will say no, it is not AS. Okay. So AS and ATS. So immediately it is not also ATS. Why it is not ATS? Because 1, 2 and 2, 1 are present. 1 and 2 are not same. What about my R2 relation? R2 is say 1, 3, 3, 2. So what you will say? So 1, 3 is there, 3, 1. 3, 1 should not be there. 3, 2 is there, 2, 3 should not be there. Yes, not there. So it is AS also and ATS also.
ATS also.
Okay. R3. R3 is 1, 1, 2, 3. So 1, 1. As soon as you see self loop, you will immediately say it is not asymmetric. But for antisymmetric, 2, 3 self loop are allowed there. So 2, 3 is there. 3, 2 should not be there. Yes, 3, 2 is not there. So it is antisymmetric. So only 3 possibilities are there. If you say this is take this is cross, that is not possible. Okay, it is not possible. Give me a relation which is asymmetric but not antisymmetric. That is never possible. So for example, you are standing here, you are in Delhi, and you will say you are not in India. That is not at all possible. This entire thing is India and this is Delhi. Okay, take snapshot. I will jump to the next slide.
Done, sir.
So the only difference in ATS and AS is that in ATS self loop allowed, in AS self loops are not allowed. Rest everything is same. Let me write it. So ATS and AS are similar. Only difference is in ATS self loops are allowed, but in AS not allowed. That's it. Okay. So one more point is coming to my mind. See, for checking of checking AS, that is very easy. Checking of AS, asymmetric. Why? For asymmetric, see, if it is antisymmetric, if AS, it should be antisymmetric. Nah? So antisymmetric should be there. And if antisymmetric is there, then it will allow self loop. So how to get rid of self loop? To get rid of self loop, we will say irreflexive. Okay, in reflexive all self loops were there, but irreflexive no self loop were there. So if a relation is antisymmetric as well as irreflexive, it will be asymmetric. So now we will simply bypass the checking of asymmetric. I will simply say, if you are able to find whether the relation is antisymmetric, we have done it. Irreflexive, we have done it. So if both are there, then it will be asymmetric. Otherwise, it will not be asymmetric. I have done equivalent sign here, equivalent symbol.
Yes.
So
Yes, sir.
asymmetric, if and only if. Let me write that also. If and only if, I double F. If and only if. So both ways you have to check. Okay, both ways it is true. So if antisymmetric and irreflexive, it will be asymmetric. If asymmetric, then it will be antisymmetric as well as irreflexive. I think it's self-explanatory thing, na?
Yes, sir.
Okay, so take snapshot. I will jump to the next slide.
Done, sir.
Okay, so now the question is, just I will give you a hint so that you should know how to apply it. So x plus y is equal to 10. Okay, yes. So if we want to check whether it is asymmetric or not, so first of all I will check antisymmetric, and rather I should first check irreflexive, because irreflexive checking is very easy. Okay, reflexive means there should be no self loop. Okay, and it is on z, on integers. So I have told you, na, 5 plus 5 is equal to 10, so self loop will be there. Irreflexive is not there. So as soon as you find it is not irreflexive, you will simply say it is not asymmetric. That's it. So if it is irreflexive, then you will check it is antisymmetric or not. If both are there, then you will say asymmetric, otherwise cross it. Simple. Is it okay?
Yes, sir. Yes, sir.
Okay, so let me jump to the next slide. So I'm just leaving all the other questions just because we have to simply check two things. First, step number 1. So checking AS. Checking AS. Step number 1. Step number 1 will be you should check irreflexive. Step number 2, you should check ATS. If both are satisfied, it will be AS. Else, not. That's it. Okay. So take snapshot. I will jump to the next slide.
Done, sir.
Okay. So now we are going to start the last type, that is transitive. So what is transitive? So x is related to y and y is related to z implies x should be related to z. For all x, y, z belongs to your parent set A. Okay, so for all x, y, z belongs to A, if x is related to y and y is related to z, then x should be related to z. That is the basic meaning of transitive. So I think you already know, for example, 1 2 is there, 2 3 is there, then 1 3 should be there, na? 2 2 are matching, then 1 3 should be there. So that is transitive. That is very simple. Okay, so for every three you can say elements in A, if x is related to y and y is related to z, then x should be related to z. So please try to focus. This is implication. So even if one of them is false, you will not check this thing. So if x is related to y but y is not related to z, no need to check x is related to z or not. Okay, similarly y is related to z but x is not related to y, no need to check that x is related to z or not. So even if both are absent, you will say okay, x is related to z, no problem, we will not check it. Okay, so if both are present, only then problem start. If both are present, then x should be related to z. Okay, so for checking transitivity, self loop will never create problem. So how to do the checking? For checking, I will simply say self loop will never create problem. Self loop never create problem. Why self loop will never create problem? For example, if we have x comma x and suppose we have x comma z also, then x comma x comma z. So finally what we should have, x is common, x comma z should be there, and it is already there. Okay, so self loop will never create problem in checking of transitivity. So you should simply ignore all the self loops. Okay, so take snapshot. I will jump to the next slide and I will give you some examples. Okay, so for example, R1 relation is 1 1 2 2 2 3 3 4. Is it transitive or not? We have to check this. So I will simply say forget about these two. These are self loops now. Forget about them. They will never create problem. Now you will check this. 2 3 3 4 is there. Where is 2 4? 2 4 is not there. So I will simply cross it. If we take R2 1 1 2 2 2 3. So now These are two self loops. Ignore them. 2, 3 is there. Where is 3, 4 or 3, 5 something? There is nothing extra. So you will simply say it is transitive. Are you getting it? So if we were having 2, 3 and 3, 4. See this. The definition was x related to y and y related to z. Then x should be related to z. Na? If x is related to y related to z is missing, then we will not check this. Okay, so I will simply say 2, 3 is there. Okay, and 3, 4 is not there. Na? So no need to check. Okay, no need to check whether 2, 4 is there or not and so on. So I will simply say it is transitive. Okay, 2, 3 is there. So matching pair of with 3. There is no ordered pair which is starting with 3. If there was some ordered pair which is starting with 3, then problem will start. Otherwise, no problem. Is it okay? Okay. So if we have say R3 relation, yes, I am audible.
Yes, sir. Yes, sir.
Okay, okay. So R3 relation, I'm saying 1, 1, 1, 2, 2, 3, 3, 5, 5, 1, 2, 1. This is a gate question. 1, 3, 2, 5, 1, 5. Is it transitive or not? So first of all, we have a self loop 1, 1. Simply ignore it. And then you should start. 1, 2 is there. So try to find all the ordered pair which start with 2. So this is starting with 2. So I will say 1, 3 should be there. Okay, 1, 3 is there. Then any other starting with 2? Yes. So 1, 2, 2, 1. 1, 1 should be there. Yes, 1, 1 is there. Next 1, 2, 2, 5. 1, 5 should be there. 1, 5 is there. Okay. So this is passed. Now you will say this thing 2, 3. 3. So starting with 3 you will check. Okay, there is 3. So 2, 5 should be there. Yes, 2, 5 is there. Then starting with 3 any other? No. Just leave it. 3, 5. So 5 is there. Starting with 5 you have to check. Yes, here we have. So 3, 1 should be there. 3, 1 is absent. You will simply cross it. No, it is not transitive. Is it okay?
Yes, sir.
Okay, so this is the way to check transitive. Take snapshot. I will jump to the next slide.
Perfect, sir.
Okay, so the next question is now we will start infinite relation. Obviously, chances are very less that they will ask on finite relation because anybody can check this out once you know the definitions. Okay, so now we will start one by one infinite relation. Say R is equal to x comma y such that x plus y is equal to 10 on z. That means on integers. So whether it is transitive or not, we have to check. So for transitivity, I will simply apply the definition. That is the formal method. That is the best method. X related to y related to z implies x should be related to z. Okay, let me write it properly. X should be related to z. So what do you mean by x is related to y? I have given you the definition. X plus y should be equal to 10. X plus y is equal to 10. What do you mean by y related to z? That means what? Y plus z should be equal to 10. So if this is equation 1, this is equation 2, from that you should be able to conclude x is related to z. That means x plus z is equal to 10. You should be able to conclude it. So from these two, can you conclude this? Let me check that out. So how we can do? Say 1 and 2. So x plus z we want. X plus z should be 10. So I will simply add them. So 1 plus 2 you do. Okay, so add 1 and 2. Add 1 and 2. What we will get? X plus z is equal to 20 minus 2y. Are you getting it?
Yes, sir.
Okay, so what we should get? X plus z should be 10, but we are getting 20 minus 2y. So immediately I will cross it. I will say it is not transitive. Okay, and it is very obvious also. For example, now since we have got this thing, we have got it. So now we can think of counter examples also. What should be the counter example? If you are able to focus 2 comma 8, 8 comma 2, both will be there na. So finally 2 comma 2 should be there because 2 comma 8 and 8 comma 2. So 8 8. So 2 2 should be there. Now 2 plus 2 is 10. No, 2 plus 2 is 4. So obviously 2 comma 2 will not be there na. Okay, so obviously it is not transitive.
Yes.
Any doubt?
No, sir. It is x plus z is equal to 20. Why did you write minus 2y, sir?
Okay, if you add them, x plus y plus
Got
y
it
plus
like
z, that
this,
will be
sir.
equal to
X
20.
plus z is equal to 20.
Uh-huh.
20 minus 2, this is the equation like 20 minus 2y.
No, I am, see, please try to listen. X plus y is 10, y plus z is also 10. You add these two, what you will get?
Yeah, fine, sir. Understood.
X plus y plus z is equal to 20. So x plus z is 20 minus 2y.
Yes, yes, sir. Yes, sir.
Take snapshot. I will jump to the next slide.
That's equal to the required equation. Yes, sir.
Mm-hmm. Okay, so let me jump to the next slide now. So the next question is same. R is equal to x comma y such that y is equal to x power I such that there exists I belongs to z, integer, on z, that means integers. So how we will check that out? Is it transitive or not? So sometimes we may completely get blanked in gate exam. No need to no need to face any kind of problem. These are very easy questions. So what should we do? Simply apply the definition. You will get the answer. Simple definition. X is related to y and y related to z should conclude x is related to z. What do you mean by x related to y? Y is equal to x power I, na? So I is some integer quantity. So you will say y is equal to x power I1. And y is related to z means what? Y is equal to z power I2. From that you should be conclude that x is related to z. That means z is equal to x power, say, some constant or some integer I3. So from that you should be able to conclude this.
X is equal to y is equal to x to the power I1. And again, when y related to z is also y is equal to z to the power
Z
I2.
is equal to, yeah, sorry for that. Z is equal to y power I2. Is it okay now? Z
Yes,
is equal
yes.
to y power I2, and from that we should be able to conclude z is equal to x power I3. Yes. So what should be done now? Z is equal to x power I3 we have to prove. So first of all, try to find the value of z in terms of x. So this is 1, this is 2. So z is equal to y power I2 and y is equal to x power I1. So simply put the value and get the answer. Z is equal to y power I2. Y is what? X power I1. So x power I1 power I2. Are you getting it?
Yes, sir.
This is saying z is equal to x power I3. We should get it. So what we have done, z is equal to, but we have z is equal to y power I2. But we want z in terms of x. So I will put value of y from here, x power I1. So finally we have got it. So z is equal to x power I1 multiplied by I2. Z is equal to x power I1 multiplied by I2. And obviously we know integer multiplied by integer is some integer. You can take it I3, I4 and so on. So finally what we have concluded, z is equal to x power I3.
Yes.
And we want this thing only. So hence proved this is transitive. 100% this will be transitive.
Understood,
Okay. Take snapshot. I will jump to the next slide.
Perfect.
Okay. So next relation is r is equal to x comma y such that x divides y on z. Okay, so x divides y on z means what? Y divided by x should be some integer quantity. So I will simply apply the definition and we will try to get what we are getting. X related to y and y related to z. This implies x should be related to z. X related to y, definition says y by x should be some integer quantity, say k1. Y related to z means what? Uh, z by y should be k2. Okay, and from here we should be able to conclude z by x should be should belong should be k3, na? I should not say belong to, I should say equal. Y by x is equal to k1 and z by y is equal to k2, and here we should get z by x is equal to k3. Conclusion should be this thing. So let me check whether we are getting it or not. So how first of all the question should come to our mind, how from these two equations we should get z by x. Simply multiply them. Let me write it properly, you will get more clarity. Y by x. Okay, y by x and z by y. So we want z by x. So how we will get z by x? Y and y should be cancelled. So both should be multiplied. So 1 and 2, multiply them. When you will multiply them, what we will get? Z by x, that will be equal to k1 multiplied by k2, and integer multiplied by integer is always integer quantity. So finally what we have got? K3. So finally we have got K3. Conclusion is correct. So this is your transitive relation.
Yes, sir.
Okay, so if you want to take any example, then you can take that x comma y, x divides y na. So for example 4 2 comma 4, 2 comma 4, why? Because 2 divides 4, and 4 should be related to 8, why? Because 4 divides 8. So from that obviously you will say 2 divides 8. So that is the intuition behind it. Okay, but I should never say, you should never follow this kind of method in gate. Sometimes confusions may come, so better is no need to go by intuition and all. That is mathematically or formal method one of the best method. You will always get correct result. Okay, so initially you may find it difficult, but it is really very easy method. Okay, take snapshot. I will jump to the next slide.
Copy it, sir.
Okay, so now I will show you some examples. Okay, so finally summary. We will build the summary. Summary is very, very important. Okay, so what we have? Reflexive, then irreflexive, symmetric, antisymmetric, asymmetric, transitive. So we will take few examples now. We will build this table. Okay, so the very first is R1. R1 is equal to, let me take a simple color. Yes, R1 is equal to 1 1 2 2 2 3, and the parent set is given as 1 2 3, because I have told you many times, without parent set we cannot guarantee anything. R2 relation is 1 1 2 2 3 3 and 2 3 1 3. Okay, this is 1 1. Okay, so R3 relation is 1 1 2 2 3 3. So if we try to analyze, this is IA, identity relation on set A, 1 1 2 2 3 3, only self loops. R4 is given as 1 2 2 3. R5 is x comma y such that x plus y is equal to 10 on Z. R6 is x comma y such that y is equal to x power I such that there exists I belongs to Z on Z. And R7 is x comma y such that x divides y on Z. Okay, so these are 7 relations, and we will try to find what are these. So first, very very easy. So 1 2 3, that is our parent set. So 1 1 2 2 3 3 is missing, so it is not reflexive. Self loops are there, so it is not irreflexive. What about symmetric? Symmetric 2 3 is there. Where is 3 2? Missing. So symmetric is not there. Symmetric self loops will not create problem. 2 3 is there. 3 2 should be there. What about anti-symmetric? So self loop will not create problem. 2 3 is there. 3 2 should not be there. Okay, so it is not there. So it is anti-symmetric. What about my asymmetric? No. Why? Because anti-symmetric as well as irreflexive. Then we should have asymmetric. What about transitive? 1 1 2 2 self loop will not create problem. 2 3. So nothing is extra there. So transitive. Because if something is starting with 3, then it will create problem for transitivity. Okay, so next is 1 1 2 2 3 3 self loops. All self loops are there. Parent set is 1 2 3, so reflexive. Immediately it is not a reflexive. Why? No self loop, but here we have all the self loops. What about by symmetric? Symmetric 1 3 is there. Where is 3 1? Absent. So symmetric is not there. Antisymmetric 1 3 is there. 3 1 should be absent. Yes, it is absent. So it is antisymmetric. Asymmetric? No. Why? Because irreflexive as well as antisymmetric, then asymmetric. Transitive 1 3 is there. At self loop already I have told you, na self loop will not create problem. Now, please do not check 1 3 3 3. So 1 3 should be there. 1 3 is always there. Okay, so self loop will not create problem. Simply leave them and now check 1 3 is there. So starting with 3, nothing is there. I will simply say it is transitive. Okay, next 1 1 2 2 3 3. This is identity relation. You can say best part of identity relation is it is always reflexive. It is never irreflexive. Why? Because 1 1 2 2 3 3 all are there, but there should be no self loop. Okay, and then what about my symmetric? Yes, self loops will not create problem. Antisymmetric? Yes, it is also antisymmetric. Why? Because self loop will not create problem. It is not asymmetric. Why? Because irreflexive and antisymmetric both, then asymmetric. Transitive? Yes, because self loop not create problem for transitivity. Yes, 1 2 2 3 R4. So reflexive? No, because there's all self loop should be there, but there is no self loop. Irreflexive? Yes. What about symmetric? 1 2 is there. Where is 2 1? No, so it is not symmetric. Antisymmetric 1 2 is there. 2 1 should not be there. Okay, yes. 2 3 is there. 3 2 should not be there. Okay, yes. So it is antisymmetric. Now irreflexive and antisymmetric both are it is, so it is asymmetric. What about transitive? 1 2 2 3. Where is 1 3? So it is not transitive. Any doubt?
No, sir.
Okay, next x plus x comma y, x plus y is equal to 10 on z. We have done it many times. Okay, so I think we should bypass it. So reflexive? No, it was not reflexive because for every integer set it is not there. It is not irreflexive because 5 5 that will create problem for us. It will be a self loop. Okay, and then what about my symmetric? Yes, it is symmetric because x plus y. See, if operator is commutative, it will be always symmetric. One shortcut is there. X plus y is y plus x, same na. So if operator is commutative means symmetric. Okay, yes. And if in place of x plus y is equal to 10 we have x minus y is equal to 10, then it will not be symmetric. Okay, yes, obviously it will not be symmetric. For example, if I say x minus y is equal to 10, okay, then immediately ordered pair will, several ordered pair will come to our mind. For example, say 10 comma 15 comma 5 will be there. Why? Because 15 minus 5 is 10. So 5 comma 15 will not be there. Why? Because 5 minus 15 will be minus 10, but we want 10 only. Is it okay now?
Yes, sir.
Okay, so symmetric it will be. And what about antisymmetric? No. Why it is not antisymmetric? 2 8 will be there, 8 2 will be there. 2 and 8 are not same. It is not antisymmetric. Let me use red color. Okay, what about my asymmetric? No. Why? Because for asymmetric we want irreflexive as well as antisymmetric, but nothing is there. So obviously asymmetric it is not. Transitive, we have just find it out. X plus y is equal to 10. It was not transitive. Okay, we have just done it. Okay, yes. So for integer part, so reflexive, yes, because we can take I is equal to 1, y will be equal to x. So every pair will be related to itself, x x y y z z and so on. So it is reflexive. What about irreflexive? No, because all self loop is there, but we want no self loop. What about symmetric? Symmetric is also not there. Okay, I think I have given you the ideas. I should not repeat here. It is just a summary. Okay, so after that antisymmetric, yes, it was antisymmetric, it was not asymmetric, and it was transitive. Okay, we have just done it. X divides y, so it was not reflexive. Okay, because 0 does not divide 0. Counter example was there. Irreflexive not, because there are lots of self loops. Symmetric no, because x divides y, then y divides x. That is not the case. Okay, antisymmetric it was not there. Asymmetric was not there. Only transitive was there. So divides is only transitive, nothing extra. Okay, so that's it. So we have done all these things. Now we should not repeat them again and again. Okay,
Yes.
and one more point I want to clarify. We have another type of relation called equivalence relation. Equivalence relation means it should be reflexive, symmetric, and transitive. If a relation is all reflexive, symmetric, transitive, then it is equivalence relation. And another is partial order relation. Partial order relation. What is partial order relation? Reflexive, anti-symmetric, and transitive. So from here we can check it out. Equivalences are 3 only. Okay, you can check this out. Reflexive, symmetric, and transitive. Reflexive, it is not symmetric, leave it. So you can check that out. Okay, R3 is the only one which is reflexive, symmetric, and transitive. Okay,
Yes, sir.
yeah. And what about partial order relation? Reflexive, anti-symmetric, and transitive. So you can check that out. It will be R2, R3, and R6. Okay, R2, R3, and R6. Okay, you can check that out. Okay, so take snapshot. I will jump to the next slide now.
Copied, sir.
Okay, so sometimes they will slightly twist the question. So let me give you the idea how they will twist it. So for example, they can give you the same relation, but set will be different. For example, R x comma y such that x divides y on z plus, they will give on positive integer set. So we have to check reflexive, irreflexive, symmetric, antisymmetric, asymmetric, and transitive. Okay, we will check all these things. Yes, so please let me know whether it is reflexive or not. Obviously x divides x, that is true. Only problem was 0, and 0 is not there because of z. Yes, so it will be reflexive. What about irreflexive? No, not at all. All self loops are there, but we do not want any. Symmetric, when x divides y, y divides x, obviously not there. Okay, for example, x divides y means what? Y divided by x is an integer quantity. Okay, so obviously when y by x is integer, so x by y will not be integer quantity. Na? 2 comma 4 will be there, but 4 comma 2 will be absent. Okay, so symmetric is not there. What about antisymmetric? Yes, obviously it will be there. We have just checked that out. Okay, asymmetric, no. Why? Because irreflexive is not there. Irreflexive and antisymmetric both, then asymmetric. Transitive, yes, 100% will be transitive. We have just done all the things. Okay, here set does not matter because we have done the formal proof. Okay, see this, y by x is equal to k1, z by y is k2, and so on. So we have done that, so no problem in that scenario. Okay, take snapshot. I will jump to the next slide.
That's it.
Okay, so I have explained it in previous class, but just for the sake of revision, if parent set is empty, okay, and relation R is subset of A cross A only, so only one relation will be possible, that is empty. So empty relation on empty set. So what are the possibilities? So I will copy it. Yes. So what are the possibilities? It will be reflexive, irreflexive, symmetric, antisymmetric, asymmetric, transitive, all. So only one relation is there, that is empty relation on empty set, which is reflexive, irreflexive, symmetric, antisymmetric, asymmetric, transitive. You can check that out yourself. So do I need to explain it, or is it okay?
No, sir, I'll do it.
Okay, yes, good. Okay, and next is if A is not empty and relation is subset of A cross A, and we want to check relation is empty relation, it will not be reflexive for sure. Why? Because something should be there in the parent set. If something is there, so obviously and empty relation is there, so self loops are not there. All self loops should be there. So reflexive, it is not possible, but rest all will be there. You can check that out yourself. Why it is irreflexive? There is no self loop, no problem. Symmetric, yes. When x is related to y, then y should be related to x. When x is not related to y, then y we need to check other things. X related to y implies y related to x. When this is not there, then we need not check it. Trivially it is true. Symmetric is there. Antisymmetric, same. When x is related to y and y is related to x, then x should be related to then x should be equal to y. When both are missing, no need to check anything. Same is the case with asymmetric. For transitive, yes, same. What we will say, x is related to y, x related to y, and y related to z. Then conclusion should be x related to z. When nothing sort of this kind of thing is present, so why we need to check other things? So trivially true, all are trivially true. Okay. Yes, take snapshot. I will jump to the next slide. So this is all about empty relation. Many times question has been asked. So empty relation on empty set, everything. Empty relation on non-empty set, except reflexive, everything.
Done, sir.
Okay, let me jump to the next question. So we are these all are standard questions. Okay, so they will say relation R is x comma y such that x is parallel to y on lines in plane. On lines in plane. So x and y are lines on the plane. Okay, so for example, this is a plane and we have lines like this. Okay, yes, and they are saying x is parallel to y. So we have to check all the possibilities. Reflexive, irreflexive, and so on. So reflexive. So you might think that x is parallel to x. We have to say like this, na? But same line is not parallel to itself because it is cutting and so on. But actual definition of parallel means slope same. When slope is same, then we will say they are parallel. What do you mean by slope? Equation of line is y is equal to mx plus c. This m is slope. Okay, for example, this is a line. So this is the c, the constant part. Okay, this is c. M is tan theta. This angle which is making with the x-axis. Let me do it properly. Okay, yes, this theta, tan theta, that is the slope. So when slope is same, then only lines will be parallel, na? So these and these are parallel. Why? Because their slope is same. Are you getting it? So
Yes,
whenever slope is same, then we will say they are parallel. So for reflexive, yes, it will be reflexive. Why? Because x and x, both lines will have same slope. Obviously, when line is same, then slope will be already same. What about irreflexive? No, not irreflexive. Why? Because all self loops are there. So, and we do not want any self loop. Symmetric. What about my symmetric? So simply you will say x is parallel to y. So can you conclude y is parallel to x? Obviously, it is symmetric. Okay, so you can say like this: x is related to y implies y related to x. So what do you mean by x related to y? X parallel to y. So you should be conclude y parallel to x. Yes. Antisymmetric. No. Immediately no. Why? Because x related to y, y related to x, and y should be same. But no, they are different lines. They are different lines on the plane. No? So it is not antisymmetric. Similarly, asymmetric cross. Why? Irreflexive and antisymmetric both, then asymmetric. What about transitive? Transitive means what? Definition will apply. X related to y and y related to z implies x related to z. So x parallel to y and y parallel to z. Obviously, x is parallel to z, na?
Yes, sir.
It is transitive. So it is transitive. Take snapshot. I will jump to the next slide. Done? Okay. Yes, and formal way of doing can be slope same, na? So you will say they have same slope. X is equal to y is equal to z. So obviously x is equal to z. We can think like that also. Okay, let me jump to the next slide. So next is r is equal to x comma y such that x is perpendicular to y on lines in plane. On lines in plane. So perpendicular lines. Okay. So first of all, reflexive. X is perpendicular to x. Can I say like this?
No, sir.
Never. So it is not reflexive. And mathematically, we should say x is having slope m1 and y is having slope m2. So m1 multiplied by m2 should be equal to -1. That is the basic meaning of perpendicular lines. So their multiplication of slope should be -1. Okay, so like this, these and these lines are parallel, so their slope multiplied, when we multiplied their slope, it should be -1. That is the technical definition of perpendicular lines. Okay, so it is not reflexive. What about irreflexive? Obviously it will be irreflexive because no line is parallel to itself. No line is perpendicular to itself. There is no self loop. What about my symmetric? So what about my symmetric? Symmetric means x related to y implies y related to x. So x perpendicular to y implies y perpendicular to x. Is it okay or not? Yes, obviously. This is x, this is y. When x is perpendicular to y, y is also perpendicular to x.
Yes, sir.
Okay. What about antisymmetric? No. Okay, because x related to y, y related to z, x related to y, y related to x is equal to y. So obviously they are not equal and they are perpendicular. Asymmetric cross, because irreflexive and antisymmetric both, then asymmetric will come. Transitive. This is important. Transitive. What is the definition of transitivity? X related to y, y related to z implies x related to z. So x perpendicular to y and y perpendicular to z implies x perpendicular to z. Is it okay? It is true or not? Try to think about it. Okay, so first of all, see this. Try to visualize when x is perpendicular to y,
No, sir,
y
it
is
is not
perpendicular to z. It is not correct. Why? Because see, this is y now, so z should be what?
In
Z
this
is
case,
perpendicular
x and
to.
z will be parallel to each other.
Very good. So z will be like this. Z is perpendicular to y. So x and z are parallel to each other. Okay.
Yes,
So x and z are parallel to each other. So this is not the case. And mathematically we can prove it. That is the beauty of mathematics. Now visualization we have done. So let me prove it mathematically. X perpendicular to y means m1 cross m2 should be equal to -1. X is related to y means what? This should be the case. Y related to z means what? m2 multiplied by m3, that should be equal to -1. So from this and this we should conclude this. That means m1 multiplied by m3, that should be equal to -1. Are you getting it now? Slope of x is m1, slope of y is m2. So from these two I have to conclude this. That is the power of mathematics. Now even if you are not able to visualize, just apply formal method and get the answer. So how we will get m1 multiplied by m3? So you will multiply these two equations. That is so obvious, 1 and 2. So what we will get? m1 multiplied by m3, that will be equal to 1 upon m2 square. Do you get it?
Yes, sir, I got it.
Okay, so that's it. So we want m1 multiplied by m3 should be -1, but we have got m1 multiplied by m3 equal to 1 upon m2 square. So it is not correct. So it is not transitive. Okay, that is the power of mathematics. So no need to visualize the things and all. Simply you can do that in Gate. Okay, take snapshot. I will jump to the next slide.
Done, sir.
Okay, so all these are standard questions. Okay, so next is r is equal to x comma y such that x is 1 inch from y on points in plane. Points in plane. So we have a plane like xy plane. You can consider it as plus x, positive xy plane. Na? So you have taken the points like this. So which points are related? When can I say this point is related to this? This point will be related to this when the distance between them is 1 inch. Okay. So now we will check all the things one by one. Reflexive, irreflexive, and so on. Yes. So please tell me, is it reflexive? X should be related to x. X related to x means what? X is 1 inch from x. Is it possible?
No.
Never possible. It is 0. Irreflexive 100%.
Yes.
Okay, because there is no self loop. What about my symmetric? See, when x is at a distance of 1 inch from y, then y is also at a distance 1 inch from x. Symmetric 100%. So when x, apply the definition. X related to y implies y related to x. X related to y means distance is 1 inch. So obviously here also we have 1 inch. So from when x is related to y, 100% is guaranteed that y will be related to x. That's it. Symmetric. Antisymmetric, immediately we will cross it. Why? Because x related to y, y related to x, both are not same point. They are different points. Okay, are you able to get it now? Antisymmetric means what? X related to y and y related to x implies x is equal to y. But here is they are not equal to y. And asymmetric, no. Why? Because irreflexive and antisymmetric, both then asymmetric. We will cross it. Transitive, that is interesting. What do you mean by transitivity? X is related to y, x related to y, and y related to z imply x related to z. Their distance is 1 inch, their distance is 1 inch. So can you conclude their distance is 1 inch? Draw this. X, Y, Z. 1, 1. So x to z distance is 2. It is not 1. We will cross it. Okay.
Yes, sir.
Take snapshot. I will jump to the next slide.
Done, sir.
Okay. And if you want to do formally see, simply we will say x is related to y means when their distance is 1. So you will say x, roughly you will say x plus y is equal to 1. And here roughly you can say y plus z is equal to 1. Okay, so from here how you will conclude x plus z is equal to 1? No, you will say 2 minus 2y. So it is wrong. And the moment you get it, you can immediately think of this intuitive example. Okay, yes, and this is 1. 1 plus 1 was 2. Okay, let me jump to the next slide. So next question is r is equal to a comma b such that a is subset of b on all these sets. Okay, so all the possible sets in this world you have taken, and you are saying two sets are related when a is subset of b. So we will check it is reflexive and so on. So what about my reflexivity? A is subset of a. We should say like this. Yes, this is true. So it is reflexive. Irreflexive, not. Immediately we will cross it. Symmetric. When A is subset of B, then can you conclude B is subset of A? No.
No.
So it is wrong. Antisymmetric. Immediately yes. Because when A is subset of B, see this. This is the beauty. A is subset of B and B is subset of A. So obviously, what is the conclusion? A is equal to B, and that is the definition of antisymmetric only. So what about my asymmetric? No, because antisymmetric and irreflexive both then asymmetric. Transitive, obviously A is subset of B, B is subset of C, conclusion A is subset of C, 100%. Is it okay now?
Yes, sir.
Take snapshot. I will jump to the next slide.
Copied, sir.
Okay, next question is r is equal to x comma y. X is less than or equal to y on r. R means real numbers. X is less than equal to y. So we will copy the things. Yes. So reflexive. X is less than or equal to y, we are saying, na? So obviously x is related to x, true. X comma x will be there, na? So it is reflexive. Is it okay?
Yes, sir.
Because less than or equal to we are saying, na? So 2 will be related to 2, 3 will be related to 3. What about irreflexive?
Yes, sir.
Why irreflexive? Irreflexive will not be there, na? Because reflexive is there. When we have all the self loops, then obviously it will not be there, na?
But it is said x is less than or equal to y. We will have self loops, no, sir?
Self loop is there, so that's why reflexive is there, na?
Reflexive is yes, sir, yes, sir.
So irreflexive will not be there, na?
Yes, sir.
What about my symmetric? When can you say x is less than y implies y less than equal to x? No, never.
No.
Antisymmetric, when x is less than equal to y and y less than equal to x implies x is equal to y, 100%. Asymmetric, no. Why? Because antisymmetric and reflexive both. Transitive, yes. Why? X is less than equal to y and y less than equal to z. Conclusion is x is less than or equal to z. Okay.
Yes, sir.
Take snapshot. I will jump to the next slide.
Sir.
Okay, so the next question is same to same question. The only difference is in place of less than equal to, we will say strictly less than y on the real numbers. So yes, reflexive.
This will
No,
go wrong this time.
yeah, because equal sign is not there, na?
Yes.
So 2 cannot be there. Why 2 cannot be there? Because 2 is equal to 2, but we want 2 strictly. 2 is not less than 2. That's why. Bas, forget about this. 2 is not less than 2. Na? That's why it is not there. Irreflexive, yes, because there is no self loop. Symmetric, no, because 2 less than 3. So can you conclude 3 less than 2? Meaningless thing.
No.
Antisymmetric, antisymmetric, yes. Okay, because x is related to y and y related to z. Sorry, x is related to y and y related to x implies x is equal to y. This is there, this will never be there. So obviously we will not check other things. So antisymmetric is there. Asymmetric, yes, because irreflexive and
It's
antisymmetric both. Transitive, yes. Why? X is less than y and y less than z. Obviously we can conclude x is less than z. Okay, so you can take snapshot. We will jump to the next slide.
Done, sir.
Okay, so yeah, and one more thing, I'm leaving this as a homework. So you have to check equivalence relation and partial order relation. Equivalence relation means reflexive, symmetric, and transitive. So it is not equivalence. Equivalence means reflexive, symmetric, transitive. Partial order, reflexive, antisymmetric, transitive. So for all the questions you can do it very easily because I have just shown you, so you can easily get the answer.
Yes,
Okay,
sir.
equivalence relation, partial order relation.
For all these questions, yes, sir.
Partial order, equivalence, partial order, and so on. You can take that. Okay. Yes. So now finally we will start counting relations. Okay. So next topic. So types of relations is over. Now we are going to start counting relations. Counting relations. So counting relation, two types of question will be there. How many? So for example, they can give you a set. A is 1, 2, 3, and they will ask you how many reflexive relations are possible, how many irreflexive relations are possible, and so on. Many times question have been asked. So counting relation is much more important than this type of relation finding because that is a bit easy task. Okay, but this will be a quite difficult, but no need to worry, we will make it very simple. So first is how many, and second type of question is smallest and largest. Smallest and largest. So what is the smallest? This set is given to you. What is the smallest reflexive relation possible? What is the largest reflexive relation possible? And so on. This type of questions they will ask you. Okay, and in fact they can ask size also. Smallest, largest, size also they can ask. Okay, take snapshot. I will jump to the next slide and we will start reflexive.
Yes, sir.
Okay. So now first is reflexive relations. Reflexive, how many reflexive are possible? So that is very simple. I have taken set as 1, 2, 3. So I will use matrix method here. Matrix method is very easy to understand. 1, 2, 3 and 1, 2, 3. So what you will say? You will say diagonal. All these diagonals, only one possibility. That means they must be present. 1, 1, 2, 2, 3, 3. They should be present, na? So only one possibility. This is upper triangular region. This is lower triangular region. So each and every element here will be having 2 possibility. 2 possibility, 2 possibility. And for diagonal only one possibility. So if we have n cross n matrix, that means what? Total elements will be n square. See, if set A is having n element,
Yes, sir.
then A cross A will have how many elements? N square.
N square elements.
We can check this out from matrix also. N square element will be there in matrix. So from these n square elements, how many elements will be there in principal diagonal? Only
Eight
n elements will be there. N, na?
elements. Yes, sir.
So these n have only one choice, and rest other elements will have two choices. They can be present, absent. It hardly matters to me. So how many elements are having two choices? N square minus
N.
n elements are having two choices. So 2 power n square minus n. Is it okay? 2 multiplied by 2 multiplied by 2 n square minus n times, so 2 power n minus n square minus n. Any doubt?
No, sir.
Okay, so this is reflexive.
Also,
Similarly, irreflexive, same answer. Why same? Here only one possibility was present only, but in irreflexive I will say all diagonals absent. Okay, so in reflexive what we will say, all diagonal elements present, all diagonal present, but in irreflexive we will say all diagonals absent. So obviously same answer, 2 power n square minus n. Is it okay?
so here we are counting how many, in fact, isn't it, sir?
Yeah, how many irreflexive relations? Yes.
Yes.
Hmm.
So in case of reflexive relations, only n
Hmm.
possibilities.
Uh,
And
n- hmm. No. In
both,
reflexive,
huh,
total 2 power n square minus n are possible. How many reflexive are possible? 2 power n square minus n. Why? Because total elements will be n square. Na? In A cross A, elements will be n square. Diagonal part, only one possibility. All should be present. So for n elements, we have only one possibility. But for rest of the elements, how many are left out? N square minus n elements are left out. So for each of that element, we have two possibility.
they can be present or absent.
Present, absent, present, absent. So 2 multiplied by 2 multiplied by 2 and so on. How many times? It is combinatorics only. So n square minus n times. So it will be 2 power n square minus n.
Sir.
And any doubt?
No, sir.
Okay, and irreflexive, same answer will be there. Why? Because here there was only one possibility, that means all should be present. For irreflexive also there is only one possibility, that means all should be absent. That's it. Okay, possibility is one only. For rest of the element, how many are left out? Total elements are n square, principal diagonal are n square minus n elements are left out, and each is having two possibility each. So 2 power n square minus n, same answer. Okay.
Yes, sir.
Yeah, so they can ask, see, sometimes they will ask direct question like A is having 1, 2, 3, 3 elements. How many reflexive relations are possible? So you will say 2 power 3 square minus 3, that means 2 power 9 minus 3, that is 2 power 6, 64. So here 64 is the answer, 2 power 3 square minus 3. Same, okay. So 2 power 6. That is 64 is the answer. Similarly, irreflexive also 64. Same. Okay, sometimes they will ask direct question. Sometimes they might ask you formulas like this. We have a set of n elements. How many reflexive are possible? How many irreflexive are possible? Same. And sometimes they may slightly twist the question. So let me jump to the next slide and show you the twisted question. Take snapshot.
Done, sir.
So what they will ask, we have a set A of n elements and relation is subset of A cross A, and they will ask you probability that a relation picked at random is reflexive. Like this they will ask. So what is the probability? Probability means you can say favorable outcome upon total outcome. Okay, so what are the favorable outcomes? So how many are reflexive? 2 power n square minus n. How many are the total relations?
N
Total
cross.
are 2 power n square.
Yes.
Okay, so what will be the answer? 1 upon 2 power n. Any doubt?
No, sir.
2 power n square, 2 power n square will be cancelled out, and
Yes.
2 power minus n is there, na? So it will come down.
Yes, sir. Yes, sir.
Okay, take snapshot. I will jump to the next slide.
Done, sir.
So now we are going to start symmetric relation. Number of symmetric relations possible. So same, we will make the matrix. So for each a diagonal element, so for symmetric, diagonal was not any problem for us. So each diagonal element will have two possibility. They can be present, absent, it hardly matters to me. So how many from here we will get 2 power n possibility for the diagonal. What about my off diagonal elements? That means upper triangular region and lower triangular region. So I will say, if here say this element is 1 comma 2, so its corresponding element 2 comma 1 will be here. So if 1 comma 2 is there, then 2 comma 1 should be there, na? So I will say like this in upper triangular and lower triangular. Upper triangular present, then lower triangular should be present. If upper is present, lower is absent, not allowed. Upper absent, lower present, not allowed. Both are absent, that is allowed. So this is allowed and this is allowed. So how many possibilities are these? 2 possibility. Okay, so 2 possibility for each element in, see, you have to take either this upper triangular region or lower triangular region. So how many elements will be there in upper triangular region? I will simply say, if total elements are n square minus n, if we do, diagonal is over, divided by 2 if I do, so number
Yes,
of
sir.
elements in upper and lower will be same, na? So that's why we will divide it by 2. So these are the total elements in either upper triangular or lower triangular, and number of possibilities are 2. So for each of them two possibilities, so 2 power this. So finally what will be our answer? 2 power n multiplied by 2 power n square minus n by 2. Any doubt?
No, sir.
So finally what we will get, this n will be added, so it will be 2 power n into n plus 1 by 2.
How
Is it
is that,
okay?
sir?
Any doubt here?
Yeah, so the last point I didn't.
Okay, so
N into n
base is same.
1 divided by 2. This I understood, sir.
Mhm. Which part is confusing? This thing?
Yeah, sir.
Okay, so no problem. See this is 2 and this is 2, same base, na? So see this, when 2 power n multiplied by 2 power m, it is 2 power n plus m, na?
Yes.
So simply say 2 power n square minus n by 2 plus n. So n square minus n plus 2n by 2. So n square plus n by 2. So n into n plus 1 by 2.
Yes, sir.
Okay.
Yes, sir.
Okay, so take snapshot. I will jump to the next slide.
Done, sir.
Okay, so next is antisymmetric. How many antisymmetric? ATS. So same scenario. We will make a matrix. For antisymmetric, I have told you self loop will not create problem. So 2 possibility. So 2 power n. For upper triangular and lower triangular region, we have to check that out. Upper triangular, lower triangular, both are present. Like 1 2 is there. So correspondingly 2 1, it should be absent, na? Both
Yes,
present, that is not allowed. Upper present, lower absent, allowed. Upper absent, lower present, allowed. Both are absent, allowed. So total 3 possibility. So how many elements are there in upper triangular or lower triangular? N square minus n by 2. So 3 power this thing. So final answer 2 power n, 3 power n square minus n by 2. Yes, please see this, and if you have any doubt, you can ask.
no, sir.
Okay, take snapshot. I will jump to the next slide.
Done, sir.
Next is how many asymmetric? AS. So same scenario, self loop. It has said no element should be there. So only one possibility. That means all should be absent, 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 and so on. For upper triangular and lower triangular, upper, lower, both are present, not allowed. This present, this absent, this absent, this present, both absent, allowed. This is allowed. So 3 power n square minus n by 2. Any doubt?
No, sir. Same as previous.
But in previous we have 2 power n also.
Sir.
Because in diagonal every element 2 possibility. But here no, only one possibility, all should be absent. So only difference is this thing. So yes, good question. Good question. They can ask like this also. AS ratio ATS. AS ratio ATS. So it will be 1 ratio 2 power n. Okay. Take snapshot. I will jump to the next slide. Okay. So next is transitive. For transitive there is no formula. No formula. So they will not ask you this kind of question in GATE. How many transitive relations are possible and so on. Okay, so now I will solve a very important questions which have been asked in GATE many times. So let me jump to the next slide, take snapshot. Okay, so we have studied principle of inclusion exclusion. We have told you A union B, that was A plus B minus A intersection B. We have minus A intersection B, and A XOR B, that was A plus B minus 2 times of A intersection B. A minus B we have done, A minus A intersection B, B minus A we have done, B minus A intersection B, and we have A complement intersection B complement. So by De Morgan's law, what is this? A bar dot B bar, that is nothing but A plus B whole bar. So that is nothing but universal set. That means A cross A minus A union B. Is it okay now?
Yes, sir. Instead of union, we have the name A cross A.
Yeah. And if we have A complement union B complement, so it will be A bar plus B bar, that is nothing but A B bar. So A cross A minus A intersection B. Is it okay now? So we have done all these things. So now they will, why I have written these again? Because they will ask you how many reflexive or symmetric are possible. How many reflexive, either reflexive or symmetric but not both. How many symmetric and symmetric but not anti-symmetric are possible. Are you getting it now? A but not B, B but not A. How many are neither reflexive nor irreflexive, like this. I have told you the keywords also for all these. Okay. So they will ask such kind of question, and they have been asking these questions repetitively. So see the beauty. How many total possible? We will do this in exhaustive way. How many types of relations are possible? Reflexive, irreflexive, symmetric, anti-symmetric, and asymmetric. Okay, we will not study transitive because there is no formula for transitive. Reflexive, irreflexive, symmetric, anti-symmetric, asymmetric. So total 5. So you just make pairs 5C2, total 10 pairs. Are you getting it now? Reflexive, irreflexive, reflexive, symmetric, reflexive, anti-symmetric, and so on. Total 10 pair will be there. And for each 10 pair, we will have 6 questions. 1, 2, 3, 4, 5, and 6. Are you getting it? Total 6 questions will be there. So 6 into 10, that is 60 questions can be asked in GATE. See the variety. Okay. So obviously we will we will not solve even one question. I will tell you how, what is the shortcut and all. So the basic thing is total 60 questions can be asked. See the variety. They can ask any question. The only thing is we should know how many reflexive, how many symmetric we can do, but this is not clear to us. Intersection. So if we are able to do intersection part, so directly and indirectly we will solve only 10 questions. Are you getting it? What will be the 10 question? Reflexive, intersection, irreflexive, reflexive, intersection, symmetric, and so on. Only we will do intersection between them. You make pairs and you simply apply intersection between them. So you will solve only 10 questions, and these 10 questions indirectly will solve all these 60 questions. Is it okay?
Yes, sir.
Because number of reflexive we already know by the formula, number of symmetric we already know by the formula, but we do not know how many reflexive as well as symmetric. That is the problem. So A intersection B we do not know. The moment we know A intersection B, I can solve A union B, A XOR B, A minus B, B minus A, all we can solve.
Yes, sir.
Okay, so yeah. So now we will solve only 10 questions. So what are the 10 questions? And by the way, we will assume A is not equal to 5. Generally, set is not empty. The parent set is not empty. So that's why we will say A is not equal to 5. Okay, in that case, we will do. So what will be the 10 questions? So reflexive, we will make pair with all. Reflexive, intersection, irreflexive. Second question will be reflexive, intersection, symmetric. Reflexive, intersection, antisymmetric. Reflexive, intersection, asymmetric. 4 pairs are over. Reflexive is done with everybody. Then irreflexive will start. Irreflexive with everyone. So irreflexive with symmetric. Irreflexive with antisymmetric. Irreflexive with asymmetric. Irreflexive is over.
Yes.
So now we'll start symmetric. So symmetric, intersection, antisymmetric, and asymmetric. Symmetric, intersection, antisymmetric. Symmetric, intersection, asymmetric. And the last 10th one will be antisymmetric, intersection, asymmetric.
Yes, sir.
ATS, intersection, AS. So we will answer these 10 questions and that's it. So these 10 questions will answer all the 60 questions. Okay. So reflexive, intersection, is irreflexive, that will be big 0. Why? Because set is non-empty. If set is empty, only then we will have only one relation, that is empty relation, and that will have, see this we have done now.
I remember, sir, we have done.
Okay, that's good. Okay, so big 0, nothing is common. So when relation is reflexive, then it will not be reflexive. When irreflexive, then it will be not reflexive. So we have done it. Okay, what about reflexive, intersection, symmetric? How to find reflexive, intersection, symmetric? So we will make the diagram. So here reflexive is saying only one possibility, but symmetric was saying two possibility for diagonal elements. So obviously when we want both, so we will take only one possibility. That means all should be present. Okay, are you getting it, na?
Yes, sir.
Okay, and what about my upper triangular and lower triangular region? Both were saying no problem at all. So what we have to take? So if for symmetric we will take, symmetric means when this is present, this should be present, na? So only two possibility were there, either both present or both absent. So 2 power n square minus n by 2. So this is my final answer. 2 power n square minus n by 2. Any doubt?
No, sir.
Reflexive, intersection, antisymmetric. So same scenario. Diagonal, antisymmetric was saying it can be present or absent, but reflexive is saying present. So obviously we will take strict part, that is present. And antisymmetric, what was it was saying? Whether this is present, this should be absent, or this is absent, this should be present, or both are absent. Three possibility. So 3 power n square minus n by 2. Any doubt?
No, sir.
Reflexive, intersection, asymmetric. Asymmetric is saying irreflexive should be there. So obviously it will be 0. Because asymmetric is saying only one possibility for a diagonal, all should be absent. Reflexive is saying all should be present. So it is contradictory. So no relation will satisfy this. Irreflexive, and these are counting problems. So do not say it is not possible. A relation which is reflexive as well as reflexive as well as asymmetric is not possible. But we are saying how many, that means counting problem. So not possible we cannot say, we have to say answer 0. Is it okay? Yeah. Next is irreflexive, intersection, symmetric. So irreflexive means only one possibility, all should be absent. And for symmetric, same 2 possibility. This is present, this should be present, and so on. So same answer, 2 power n square minus n by 2. Similarly, irreflexive and antisymmetric, same. Only one possibility for diagonal, all should be absent. For off diagonals, so 3 possibility now. This present or this absent, this present or this absent, or both are absent. So 3 power n square minus n by 2. Same formula still now. See the same formula. Irreflexive and asymmetric. What should be the answer? Irreflexive and asymmetric. Try to get it. So what should be the answer? See, irreflexive is saying only one possibility for all the diagonal, absent. Asymmetric is also saying so, all should be absent.
Yes, sir.
For irreflexive, everybody is having 2 possibility. Okay, and total of diagonal elements are n square minus n, and that was 2 power n square minus n. That was irreflexive, no? Because 2 possibility for each and every element. But asymmetric, what it is saying, 3 possibility for half of the elements. So 3 power n square minus n by 2. And in fact, we can think like that also. Asymmetric is proper subset of irreflexive. So whenever we have got asymmetric, it will be 100% irreflexive. So answer was directly number of asymmetric relations. Asymmetrics were 3 power n square minus n by 2 only. Check this out.
Sir, I checked it.
So same answer, 3 power n square minus n by 2. Okay, because intersection we are finding, so AS intersection IR will be AS only. Next, symmetric intersection antisymmetric. This is beautiful. Symmetric intersection antisymmetric. So can a relation be symmetric as well as antisymmetric? Yes. For the off diagonal, only diagonal elements 2 possibility. Okay, present absent, both are saying same, na? Symmetric also, antisymmetric also. But for diagonal, off diagonal elements, upper triangular and lower triangular region, symmetric is saying this is present, this should be present, but asymmetric is saying contradictory thing. So nothing should be added more. So only 2 possibility for n elements. So it will be 2 power n. Is it okay?
Yeah, sir.
Okay, so next is symmetric intersection asymmetric. This is very, very interesting. Symmetric is saying what? Symmetric is saying diagonal elements 2 possibility. Let me write with another color. This is important. Symmetric is saying diagonal elements 2 possibility, but asymmetric is saying only one possibility. 2 possibility is saying symmetric, asymmetric is saying only one possibility. That means all should be absent. Symmetric, for a symmetric it was hardly matter. Self loop can be present or absent. But what about my off diagonal elements? They are contradictory. They are contradictory. Okay, why they are contradictory? Because one is saying this present, this should be present, but asymmetric is saying no, it should not be the case. So we will say that there should be no relation which is symmetric as well as asymmetric. But if we see carefully, empty relation was both. So empty relation number 1 only. So number of relation which is symmetric as well as antisymmetric is only 1. That is nothing but 5. Is it okay?
Sir.
And the last is antisymmetric and asymmetric both. Antisymmetric and asymmetric. So what antisymmetric was saying? Let me draw it. What antisymmetric was saying? Diagonal 2 possibility.
2 possibilities.
And only 1 by asymmetric. So obviously we will take the lesser part 1. And what about my off diagonal? Yes. They were saying same thing only. Either both are absent, either both are present. Sorry, both are absent or 1 present, 1 absent. So 3 possibility. So 3 power n square minus n by 2. Is it okay?
Sir.
Okay. And you can visualize, since I have told you many times, so we can easily visualize. This is irreflexive and this is antisymmetric. The common part is asymmetric. Because I have told you now, when relation is irreflexive as well as antisymmetric, then it is asymmetric. So this thing we can visualize.
Sir.
Okay, now take snapshot. I will jump to the next slide, and now we will start smallest and largest relations possible. How many is over? So 10 questions we have done. So these 10 will solve 60. So I'm not giving you numericals because it will simply waste our time. But simply as a sake of homework, you can take a set A which is having 4 elements. So now you will try to find how many are reflexive intersection symmetric, how many are reflexive intersection anti-symmetric, sorry, reflexive union symmetric. Na? And intersection we have done only like this. You will find reflexive union, asymmetric, like this, and so on. You can find any questions. I think we should not waste time here because we have done the crux, main part we have
That's
done.
it.
Take snapshot. I will jump to the next slide.
Okay, sir.
Okay, so now we are going to find the number of relations possible. That is also very important. So number they will ask many times. So smallest, sorry, number we have done, size, smallest, largest, smallest, largest. Okay, and we will say smallest size, largest size. Okay, and here we will say relations. So reflexive, then irreflexive, then we will say symmetric, antisymmetric, asymmetric, transitive, and then equivalence relation, and then partial order relation. Yes, it is very thick line. Okay, so let's start it. So the very first one is reflexive. Smallest reflexive relation possible will be what? So we have a parent set. Parent set is given to us something which is having say n elements, and relation is subset of A cross A. So it should be on the same set. If it is on different set, then we these definitions are meaningless. So these definitions are valid only if it is on the same set. Okay, so smallest possible reflexive smallest possible will be identity relation IA, because all the self loop should be there na. So that will be identity relation possible. Smallest largest will be what? A cross A itself.
Yes.
So smallest size will be n, largest will be n square. Irreflexive smallest, empty relation phi. Reflexive empty was not the smallest. Why? Because self loop should be there. Na? It is non-empty set. So now without wasting our time, I will simply say smallest, everything will be phi till transitive. Any doubt?
Okay, sir.
So smallest was, we have done all these things. Na? So smallest is this. So now largest. For irreflexive, what I will say, self loop should not be there. Na? So largest will be what? A cross A minus IA.
Sir.
Okay, so size will be, smallest size will be everywhere phi na, so it will be 0, no doubt. Largest size will be n square minus n. For symmetric, your universal relation A cross A will be symmetric, no problem. Size will be n square. Antisymmetric, for antisymmetric we cannot have this universal relation. Why? Because upper triangular lower triangular will create problem for us. So maximum size largest can be IA plus upper triangular region, or you can say IA plus lower triangular region. One and the same thing, size is same na. So largest size will be n plus n square minus n by 2. Any doubt?
No, sir. I just answered it.
Okay, so what about my asymmetric? For asymmetric, you will say only upper triangular region or lower triangular region. We cannot have identity relation in between that, because asymmetric will never say self loops. So largest will be n square minus n by 2. What about my transitive? Universal relation is transitive, A cross A. So size will be n square. For equivalence relation, it should be reflexive, symmetric as well as transitive. So smallest will be IA. Okay. And largest will be what? Reflexive largest A cross A. Symmetric is this. Transitive is this. So obviously A cross A is the largest. So smallest size is n and largest is n square. What about my partial order relation? Reflexive, antisymmetric and transitive. So smallest will be again IA. Okay, because reflexive will say IA, antisymmetric will say empty, transitive will say empty. So if you take empty, obviously it will be not reflexive. So IA, identity relation. And for okay, and for largest size, obviously we will go by smallest now, because A cross A is okay, but it is not antisymmetric. So for antisymmetric, we will take this part. So IA plus lower triangular region, IA plus upper triangular, or IA plus lower triangular, one and the same thing. Or okay, so smallest size is n, largest is n square plus n by 2. I have directly written it. You can solve it. No? It will be what? N square plus n by 2. That is nothing but n into n plus 1 by 2. Are you getting it?
So finally we write n into n plus 1 by 2 here also.
You can write it. N into n plus 1 by 2. N into n plus 1 by 2. You can solve it. Na? 2n n square plus n by 2, we will get it. Same thing.
But here, so it was n plus n square minus n divided by 2 for 80 years. And for POR, we wrote only n square plus n by 2.
No, I have just solved it. N into n square minus n by 2. You simply solve this, but we will get.
That is n square plus n by 2.
So that is n into n plus 1 by 2 only. Same thing.
Yes, but I asked you that only, sir. Thanks, sir.
Okay, take snapshot. I will jump to the next slide.
Stop it, sir.
Okay, so now we will start the next topic, that is closure. So we are going to study total 5 types of closure: reflexive closure, symmetric closure, transitive closure, reflexive symmetric closure, reflexive transitive closure. Total 5 types of closures are there. So if we have a relation, say set parent set 1, 2, 3, and if I type a relation R as 1, 1, 2, 2, 2, 3. Now, what should be the reflexive closure? Reflexive closure means you can add some elements in such a way, minimum number of elements should be added in such a way the parent relation becomes reflexive. We can add, we cannot subtract. Okay, so first of all, we will copy this relation as it is: 1, 1, 2, 2, 2, 3. First of all, I have copied. Then I will check, is it reflexive? No, because 3, 3 is missing. So simply add it. That's it. This is reflexive closure. Okay, so simply copy, first of all, simply copy the relation and add only those elements which are missing. That's it.
To make it reflexive.
Yes, to make it reflexive. Now, if by chance this relation itself is given to you, you will say, okay, it is reflexive closure only. For example, if I say a relation R is given as 1, 1, 2, 2, 1, 2, 3, 3. This relation is given and they are saying you to find reflexive closure. You will say same because it is already reflexive. That's it. Okay, similarly, we can find symmetric closure also. So if I want to find symmetric closure for this relation, symmetric closure, let me use another color. Symmetric closure will be, first of all, I will copy it. And then what I will say, self loop will not create problem. 2, 3 is there, 3, 2 is missing. Add 3, 2, that's it. Over. Okay. Similarly, we can find transitive closure. Transitive closure will be same because it is already transitive. 1, 1, 2, 2 self loop will not create problem. 2, 3 is there and no element is starting with 3. No problem. I will simply say it is transitive closure. Okay. Yes. Next is reflexive symmetric closure. So first of all, we will copy this 1, 1, 2, 2, 2, 3. So simply add those which will make reflexive as well as symmetric. For reflexive, I will add 3, 3. For symmetric, I will add 3, 2. That's it. Done. Okay.
Yes, sir.
Yes. Last is reflexive transitive closure. RTC. So transitive, it is already, it is transitive. So only one we will add 1, 1, 2, 2, 2, 3, 3, 3 I will add. That's it. Is it okay?
Yes, sir.
Take snapshot. I will jump to the next slide.
Okay, sir.
Yes. So transitive closure is the biggest question. They have been asked many times. These are trivial. Anybody can answer them very, very easily. Okay. And by the way, they will ask question on infinite relation. I have just shown you the finite relation just to clear the basics so that you get more clarity how to find them. Okay, no doubt they have asked question on reflexive closure, symmetric closure also, but they will try to find them on infinite relations. They will not give you these small such relations. Anybody can find them. Yeah, transitivity can sometimes create problems. So let me show you idea of transitive closure. So for example, we have a parent set A in which we have 4 elements. Relation R is 1, 1, 2, 2, 1, 3, 3, 2, 2, 4, 4, 1. So we will say self loop will not create problem, but for others 1, 3, 3, 2, then 1, 2. You will add it. Okay. Then nothing there. Okay. 3, 2, 2, 4, then 3, 4 we will add. Okay. But the problem is when we have added 1, 2, that will create problem with 2, 4. 1, 4 also we have to add. Are you getting it?
Yes, sir.
That is very big problem. 1, 3, 3, 2 we will add 1, 2. It's okay. Now this newly added will again create problem for this.
1, 4 has to be added.
It is difficult. It is not that easy. So now let me show you the shortcut how we can find transitive closure. So we will use graphical method for that. So the parent set is having 4 elements. So I will make 4 nodes. 1, 2, 3 and 4. And I will make a digraph. 1 to 1 is there, okay, self loop. 2 to 2 is there, okay, self loop. 1 to 3, okay. 3 to 2, okay. 2 to 4, okay. 4 to 1. So now we will simply say what will be the transitive closure. I will simply start. I will blindly write 1. With 1 I will write all the nodes to which we have a path. Forget about length of path. You will simply say there exists a path. 1 to 1 there is a path. Simply write 1, 1. 1 to 2 is there a path? Yes, there is a path. Forget about length. There should be a path. 1 to 2, yes. 1 to 3, yes, obviously. 1 to 4, yes. 1 to 4, yes. 1 to 4 will be
We are
added.
going via other nodes, but still we have a path.
Yes. So for 1 it is over. Now for 2. 2 to 2. So this is very beautiful shortcut. 2 to 2 is over. 2 to 1. 2 to 1. Yes, we have a path. 2 to 3. Yes. 2 to 3. No. 2 to 3 there
No,
is, I
we
think,
don't have.
no path. We do not have. 2 to 4. Yes. Then 3 to 3 to 1. First of all, check 3 to 1 is there a path?
No.
Yes.
No.
Yes. Yes. Yes.
Oh,
Hmm.
3
3
to
to
2,
2.
2
2 to
to
4.
1. Yes, sir. Yes, sir.
3 to 1 is there. Then 3 to 2. Yes, obviously. 3 to 3. You have to check 3 to 3 also. So can you come back to 3 starting from 3?
Yes, sir.
3 to
From 1
2.
will dot
We will
7.
come. 3 to 3 will be there. 3 to 4. Yes.
Yes, sir.
Then 4 to 1. Yes. 4 to 2. Yes. 4 to 3.
Yes,
Yes.
sir.
No. 4 to 3. Yes. 4 to 3 we have. 4 to 4.
Yes, sir.
Yes. 4 to 4 is also there. So
Okay.
which was missing?
Only
2 to 3.
2
2
to
3
3.
was missing.
Hmm.
But 2 to 3 is also there. See this 2 to 4, 4 to 1, 1 to 3. 2 to 3 is also there.
Yes, sir. Yes, sir. Yes, sir.
So we have to add 2 to 3 also. So everything is added finally. Okay,
Sir.
and this thing we cannot find from here. It will be next to impossible for us.
Yes, yes.
Okay, so this is the very beautiful shortcut which we should remember to find transitive closure. And if you want to define formally what exactly is transitive closure, transitive closure is
Okay.
r power 0 union r power 1 union r power 2 dot 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 up to infinity.
So,
We
you're
will
not
start.
audible.
You
Okay,
will
you
not
were
start
not
with r power
audible.
0.
Uh,
Come again.
You were not audible, sir, for some time.
Okay. Yes, so what I was saying, let me do it again. Transitive closure means r1 union r2 union r3 dot 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 up to infinity. That is the formal or mathematical definition of transitive closure.
Screen is lost now, sir.
Okay, so let me check that what is happening. Yes, connection problem. Just wait for a minute. Now screen visible.
Yes, sir, it is.
I'm audible now.
Sir. Sir.
Okay, so transitive closure means formal definition or mathematical definition is r power 1 union r power 2 union r power 3 up to infinity. That is the formal definition. So now r power 2 is ROR, r power 3 is ROR, and so on. And I have told you while discussing composition of relation, this was composition, ROR. I have drawn this diagram and I have told you how to find R3, how to find R4. 4 length, R3 means 3 length path, R2 means 2 length path, R1 means 1 length path, and so on.
Yes, sir. Yes, sir.
Okay, so when we will union them, so directly and directly, this means what? There exists path from one node to another node. That's what we have done here. This is the shortcut. So this shortcut has been developed from formal definition itself. Okay.
Understood.
So one length path. This is saying 2 length path. And so on. So we want either 1 length or 2 length or 3 length or 4 length and so on. So directly and indirectly, transitive closure means in digraph there exists a path. That's it. Yes, take snapshot. I will jump to the next slide now.
Yes, sir.
Okay, so let me give you another example. Parent set is 1, 2, 3, 4 and relation is given as 1, 1, 2, 2, 1, 3, 3, 1, 2, 3. And they want us to find transitive closure. So how to find that? See the parent set and then talk. Okay, do not see this. In parent set we have 4 elements. I will make 4 elements in the digraph. And now I will see this 1, 1 to 1, okay, 2 to 2, okay, 1 to 3, okay, 3 to 1, okay, 2 to 3, okay. So do not get confused in GATE exam. No doubt there is no path to 4, but we have to draw 4. Sometimes it might confuse you. So better is from the parent set you make it. Okay, and then obviously you can cross it also, because there is nobody can take us to 4, because 4 is isolated, na? That's why. Yes. So what will be the transitive closure? So there should be a path. So what we will say, transitive closure will be 1 to 1, 1 to 2. 1 to 2 is there? No, 1 to 2 is not there.
No, sir.
I will simply say why, because from 2 there is only outgoing edge, there is no incoming edge to 2. So how we will get 1 to 2? 1 to 3, yes. 1 to 4, I have simply said forget it. 2 to 2, yes. 2 to 3, yes. 2 to 1, yes.
Yes, sir.
Then we will start with 2 to 4, forget it. 3. 3 to 1. 3 to 1, yes, directly we have a path. 3 to 2,
No, sir.
no path, no path. 3 to 3, yes.
Yes, sir.
So this is our transitive closure.
Okay.
Yes, so that's it. So let me see the time. Okay, we have 1-2 minutes left. So okay, reflexive symmetry closure. So I think I have given you the idea. Okay, just for sake of practice, one question, just one question. Take snapshot, I will jump to the next slide.
Done, sir.
Reflexive symmetric closure. Parent set A is 1, 2, 3. Relation is 1, 1, 2, 2, 1, 3, 3, 1, 2, 3. This is a relation and we want reflexive symmetric closure. So first of all, I will copy it. And then I will check for reflexive. 3, 3 should be there. 3, 3 is missing, simply add it. For symmetric, forget about self loop. 1, 3 is there, 3, 1 is there. Okay. 2, 3 is there, 3, 2 is missing. Simply add 3, 2. That's it. Done. Okay. Yes, so these are very simple questions. Okay. Yes, so that's it. So we will stop here itself. In the next class, we will start from here. Okay, so we will study reflexive transitive closure is left. We will study that in the next class. Okay.
Yes, sir.
Okay then. Good night. Bye bye.
Good night, sir. Thank you, sir.
Okay.